Hello बच्चों, let's read this question. A bullet is aimed at a target on the wall, a distance L away from the firing position. Because of gravity, the bullet strikes the wall a distance del y below the mark, as suggested in the given figure. Now, if the distance L was half as large and the bullet had the same initial velocity, how would del y be affected? So students, इस क्वेश्चन में हमें एक बुलेट दिया गया है. Let's say this is the bullet and this is the wall. इसे इस पॉइंट पर हिट करना है, बट ग्रेविटी की वजह से ये कुछ यूं ट्रैवल करता हुआ डेल वाई डिस्टेंस नीचे गिरता है और इसे लेट्स अज्यूम v वेलोसिटी से फायर किया गया और द डिस्टेंस बिटवीन बुलेट एंड द वॉल इज l. नाउ अब यदि इस बुलेट को l/2 डिस्टेंस से छोड़ा जाए with same initial velocity v, this is l/2, तो हमें बताना है कि इसके करस्पॉन्डिंग डेल्टा वाई डैश कितना होगा. दिस वाज डेल्टा वाई. So students, please note the key concept of this question. Which says that in a projectile motion, horizontal component of velocity remains unchanged. This is because in x direction no force acts on that object और इसकी वजह से उस ऑब्जेक्ट पर कोई एक्सेलरेशन भी नहीं आता, इसीलिए उसकी वेलोसिटी में कोई भी चेंज नहीं होती. बट इन y direction due to gravitational force, a constant acceleration g acts on the object. In case 1, when bullet was fired at distance L with speed v, we can say L equals to velocity into time t. In this is in x direction. Now in y direction, using second equation of motion, we can calculate this delta y. Now delta y is given as initial velocity in t direction, y direction into half into acceleration in y direction into t square. So delta y equals to initial velocity in y direction was 0. So this will be 0 plus half into acceleration in y direction is g into time t square. We can use time t equals to L upon v. Now substituting t here, del y equals to half into z into t square, that is L square upon v square. Now students, what happens when bullet this is fired from distance l/2 but with same speed v, we can write in x direction l/2 equals to velocity into time t dash. In this case, from here we can write t dash as l/2 into v. Same procedure in y direction. Let's say this time it falls a distance of del y dash. So del y dash equals to uy into t plus half into acceleration into y into t square. Del y dash equals to, again, even in this case, when distance was L by 2 from the ground, the initial velocity in y direction was 0, plus acceleration in y direction is g into t dash square. This will be t dash square. So students, del y dash we can write half into g into t dash. We calculated t dash as L upon 2v. L upon 2v whole square. Del y dash equals to 1 by 2 into g into L square upon v square into 1 by 4. And this was del y. You can see this was del y. So this will become del y upon 4. So students, when length was half, the vertical distance become 1 by 4. I hope you understood the concept, students. Thank you.